Chapter name is students. We are going to study the next chapter. The chapter name is time value of money. The time value of money is very important chapter. Time value of money is an idea that money available at the present time is worth more than the same amount in the future due to its potential earning capacity. For single period is future value is equal to present value 1 plus I there. Um, FEN is future value of money at the end of the period, and PV is present value or sum of the money today, and I is the annual rate of interest at which the sum of money is invested, and is the number of years which the sum of the money uh, compounded. Now let's have a look in this little diagram. The diagram is, this is time, this is number of years, and this is the cash flow for the number of years that we want to invest in the cash flow that we get each and every year. That's the basic concept of the time value of money. Calculating future value using future value table is multi-period. In the exam, you will be given the table like this, or you can buy yourself, or if you have any kind of textbook like this. I have taken the textbook from this one. At the back of the book, you will get the list of the present value and future value factors that you can calculate, or that will help to get exact number of how much factor you need. So I will give you one example here. If you invest rupees 100 today in an interest rate bearing account with 10% interest in 2 years. So the formula here is future value of n is equal to its present value future value interest factor I and n. So present value is 100. Future value interest factor is how much was the percentage is 10%. How many number of year? Number of year is 2 years. So in this example, if you look, the future value interest factor is 10% here, which is over here, and number of year is given on the column side. So you will have a look, number of year n is equal to 2, and you look the rate of percentage in vertical, which is in row, is 10%. So we find out in this way the common factor is 1.21. So you multiply by 1.21. So you get in this way 1 to 1 is the future value. If you see in this diagram, this side is the time period 1, 2, 3, 4, 5, and the vertical side is the the rate of interest. So when the rate of interest increases, for example from 0 to 15, the value is going up for the 3. Furthermore, if you increase up to the 15%, the value is going 5. So in this way, when the rate of interest is increased, future value is proportionate relationship with a rate of interest. Now let's have a look in the present value of the money. So the present value of money you can calculate is future value of money divided by 1 plus I n. So to calculate the present calculating present value using present value interest factor is multi-period time is future value n plus PBI of interest. For example, let's take the this example. The example here is, let's take the future value is 1 to 1, 1 to 1, and present value interest factor, let's have a look what's the 10% in 2 years. Let's find out the present value interest factor from the here. We can get the present value interest factor in 10% in 2 years is 0.8264. If we multiply 121 by 0.8264, we get 99.999, which is 100 rupees. To clarify this concept, let's have a look at this picture. In the lower rate of interest, the present value is 1. When you increase the interest rate 5%, and the present value goes down to 0.5. If you increase the interest by 10%, the present value goes to 0.5. And if you increase the rate of interest by 15%, the present value goes to 0.5. So in that case, we can say that there is a negative or the alternative relationship between rate of interest and the present value. That means if you increase the rate of interest, the present value will be go down. This is the very basic concept of the time value of money, which is very important to bear in mind before we go to the next section. The number of years. Finding the number of years. Suppose you invest rupees 2000 today at 8% annual interest rate. How long it takes your investment to double? So it is asking us the number of years to take to double our investment, which is 2000 rupees. We can use the formula for here is future value is equal to present value, 1 plus I is equal to n in indices. So the present value is 2000, 1 plus I n, and the future value is 4000 because it is asking the amount to be double in number of years. So we get here 4, 1 plus I is rate of interest is 0.08 number of year. So 4 is equal to 2, 1.008 log 2 is equal to 1.08. Now we take taking log on both sides, uh, which is n log 1.08 is equal to log 2. So we get number of year is equal to log 2 divided by log 1.08. If we calculate the log 2 and log 1.08 in our calculations in our calculator, we get the figure of 0.3010 divided by 0.0334. In this way, we get 9.01 years. And sometime we'll be asked to find out the rate of interest. To find out the rate of interest, let's extract those rate of interest from this formula. So in this formula, we are given that the present value is equal to present value future value divided by 1 plus I and n. So if we break down the formula like 1 plus I and future value and present value, then we get 1 plus I is equal to future value present value is 1 by 2. The rate of interest we get is future value divided by present value 2 minus 1. So in this way we can get the rate of interest in this way. You deposit rupees 3500 in saving account today, that grows to future value rupees 5000 in 5 years. Then find out the rate of interest. Let's use this one. Future value is 5000, present value is 3500, number of year is 5 year, then 1. In our calculator we get this one 1.074 minus 1, interest is 0 0.074. If you multiply by 100%, it is 7.4%. Or we can use this formula. The present value is 3500 divided by 5000 future value, PVIF, and let's divide 3500. We get 0.74, PVIF 0.7. Now, looking at present value interest factor table at 5-year row, the factor 0.7 lies between 7% lower rate and the 8% higher rate. Therefore, to obtain the exact interest rate, we interpolate the result as follows. Interest rate that we can find out, lower rate plus factor 8 lower rate minus exact factor divided by factor 8 lower rate minus factor 8 higher rate, and this one is multiplied by higher rate minus lower rate. So we know that the lower rate is 0.7. So in the calculator we get factor 8 lower rate is 0.7130 minus factor exact factor is 0.7, which is this one, divide by again factor is lower rate 0.713 minus factor is higher rate is 0.6806, higher rate is 8%, lower rate is 7%. We get the figure 0.7 plus 0.0130 divided by 0.0324 multiplied by 1%. So in this way we get 7.4%. So the rate of interest is 7.4%. Now let's have a look in another lesson. The lesson is known as annuities. This is also one of the important topic in financial management. Uh, the annuities. Annuities is a series of payment of fixed amount of at each equal intervals of time for a given period of time. So there are two type of annuities. One is ordinary annuities, and another is uh, annuity due. Just have a look in this figure. What is the difference between the ordinary annuity and the annuity due? So, in the ordinary annuity, the equal payments are made at the end of the terms. For example, this is number of year 0, 1, 2, 3, 4, and the payments is made at the end of the year. For example, 1, 2, 3, 4. If you look in the annuity due, this is time duration. Time duration. 1000 is the number of the installment payment. So the installment payment is made at the beginning of the time. For example, in the 0 or 1 or 2, 3. To calculate the ordinary due, this is the formula. Future value of annuity is a payment 1 plus I power n minus 1 divided by I, where FBA means future value of an ordinary annuity for number of years, and PMT is known as annual amount of equal payment or installment. N is equal to number of compounding periods. I is equal to annual interest of which its payment is compound. Let's take one example. Suppose we invest rupees 1000 at the end of the each year for 3 years in a security paying 8% annual interest. How much he will have at the end of the 3 years? So let's calculate from the ordinary annuities. We have formula here. Here is future value of annuity and is equal to payment. Payment is number of installment, which is 1000, brackets. I is equal to 1 is equal to 1. I is equal to, what's the interest rate? 0.08. Then power n is number of year is 3 years minus 1. 1000. I is equal to 0.08. 1.08 power final is 3246 rupees. This is the final amount. So let's have a look in the tabular method. The tabular method is very simple, uh, where we have a look the annuity tables. The future value is payment, future value, interest factor, annuity, and an I. So we get 1000, and if you look in the tabular, we get the figure 3 point in this way, 32464. Now let's have a look in the future value of annuity due. The formula is payment I plus 1 plus I brackets n power minus 1 and bracket close divide by I, and the only difference is we get 1 plus I is the extra one. So the equal payments are made at the beginning of each equal interval throughout the period. Let's take this the same example. We know that the payment is 1000, rate of interest is 0.08%, number of year is 3 minus 1 divide by 0.08, then in bracket now we get 3246.4 multiplied by 1 1.08 rupees 350611. Let's solve this problem from the tabular method. The payment is 1000. Future value annuity due 3.2464 and 1 plus 0.08. In this way, 32464 multiplied by 1.08 rupees 3506.1, same as this value. Before we calculated the equal amount of installment or cash flow every year, but now we're going to have a look in uneven cash flow streams. That means every year the cash flow will be uneven. For example, here at the end of year is 1 2 3 4 5, and the cash flow is in year 1 it's 100, and year 2 it's dollar 150, and year 3 is 200, and as on. So to calculate the present value, the formula is cash flow 1 divided by 1 plus I is equal to power n plus CF2 and so on. So let's take this example. The appropriate rate of interest is 10%. So the present value you can calculate by cash flow 1, which is cash flow 1 is 100 and 1 plus rate of interest is 10%. Number of year is 1. Cash flow 2 is 150. 2. Cash flow 3 is 200. Number of 3 is 250. 1 plus 0 1 4, and year 5 is 400. 1 plus 0 0.1 power 5. Let's get this. 1.1 power 1 plus 150, 1.1 power 2 plus 200, 1.1 power 3 plus 250 divided by 1.1 power 4 plus 400, 1.1 power 5. Let's use the calculator for this. 1 plus 123.96 plus 150.26.75 plus 248.36. If you add up all of this, we get $784.24. This is how we can calculate the uneven cash flows present value. Now, let's check the exam style problem. Here, one question here. The question is, an investment offers you to pay rupees 10,000 annuity for 3 years. Then the investment pays you additional rupees 40,000 and 50,000 at the end of the year 3 and 4 respectively. Assume appropriate discount rate is 9%. Will you pay rupees 90,000 today for this cash flow stream or not? Okay, let's find out whether the present value will be more than this 90,000 or less. If the present value is less than this project is not worth. If the present value is more than or equal, then we accept the investment opportunity. So in this way, we get here years, number of years, cash flow, present value interest factor at the rate what the percent 9%, then present value 0 1 2 3 4. Cash flow is 10,000. Year 1 is 10,000. 2 is 10,000 as well. But after 3 and 4, it is 40,000. Then 50,000 at the year 4. So we look at the present value interest factor tables on 9%. So we get is 1 0.9174, 0.417, 0.7722, and for year 4 it's 0.7084. 10,000 multiplied 1 is obviously 10,000. 10,000 multiplied by 0.97 is 9174. 8417. 40,000 multiplied by 0.7722, we get 30,888, and 50,000 multiplied by 7084, we get 35,420. So let's add up all together. How much we get? 30,888 plus 8417 plus 9174 plus 10,000. So we get 93,899. So like I said earlier, the present value is greater than 90,000. So this project is okay. So we'll be able to pay all of those cash flows within the 4 years. So we can accept this project, and this is really good project. Now let's have a look for the calculations of future value of uneven cash flow. We have done the present value before. Now let's do the future value of the uneven cash. For the future value of uneven cash, the formula is here. Cash flow 1 in bracket 1 plus I and number of year minus 1. And similarly, cash flow 2 I plus 1 plus I number of year minus 2. In this way, the cash flow n, then 1 plus I and number of year is power n minus n. So this is the exactly same problem I have taken before. So let's put this value to this formula. Future value of n is equal to cash flow 1 is 100, 1 plus rate of interest is 9%. The number of year is 5, so 5 minus 1 plus another cash flow is 150, 1 plus 0.09, 5 plus 5 minus 2. Cash flow 3 is 200, 1 plus 0.09, 5 minus 3, 250, 5 minus 4 plus 400 cash flow multiplied by 1 plus 0.09 power 5 minus 1, 5 minus 5. So in this way we get 1.094 plus 150 1.093 plus 200 1.09 2 plus 250 multiplied by 1.09 1 5 minus 4 1 plus 400 1.09 Let's use the calculator for this. Then we get the value 146.41 plus 199.65 plus 242 plus 275 plus 400. So altogether we get 1263.06. Let's solve this problem in tabular form. So here cash flow, future value interest factor at 9% and future value 1 2 3 4 5 4 5. The cash flow is 100 in 100, 150, 200, 250 and 400. And if you look in the future value interest factor table, we get 1.4641, 1.3310, 1.21, 1.1, and this one is 1. Now let's multiply this. 100 multiplied by 1.4641, 146.41, then 150 multiplied by 1.331, we get 199.65. 200 multiplied by 1.21, 242, 250 multiplied by 1.1, 275, then 400 multiplied by 1, 400. Let's add up all of this. This should be 146.41 plus 199.65 plus 242 plus 275 plus 400. Exactly 1263.06. From the exam perspective, this is a really important chapter. When you look at the old paper, this is the sure question. Every time in exam it comes. It's really easy to calculate, quite calculative. But if you understand the basic knowledge, basic techniques, then you will be fine. Here, the determinations of annual payment. This is the formula. The payment is amount of loan divided by present value interest factor annuity, number of year and rate. So I will give you one example. Let us suppose a loan of rupees 10,000 is to be paid in four equal installments, including principal and 10% interest per amount. So prepare the loan amortization schedule for this. First, the loan amount is 10,000. Then present value interest factor uh, annuity is rate of number of year is 4 years. Rate of interest is 10%. The factor is 3.1699. 1000 by 3.1699, we get the installment amount of rupees 3154.67. Now let's prepare the loan amortization schedule. Uh, the column number 1 is year, column number 2 is beginning amount, column number 3 is payment, column number 4 is interest, column number 5 is repayment of principal, and 6 is ending balance. The beginning amount is 10,000 and the payment is 3154.67. This is the annual installment payment for 1 year. So uh, we can put straight away here 3154.67 year 1, 3154.67 year 2, 3154.67 year 3, and 3154.67. To calculate the column 4, we have to multiply column 2 by 0.1. So how much we get if we multiply 10,000 by 0.1, we get 1,000. And column number 5 is 3 minus 4. 3 minus 4 is this column minus by this column. So let's subtract 1,000 from 3154. We get 2154.67. So ending balance is column 2 minus column 5. So let's minus this 215467 from 10,000. 10,000 minus 2154.67, it is 7854.33. The ending balance becomes the beginning balance for next year. So beginning balance is for for year 2 is 7845.33. Now let's calculate column 4. Column 4 is column 2 multiplied by 0.1. So this multiply, we get 784.533. Column 5, 3 minus 4, 2370.137. Column 6 is column 2 minus 5, 5475.193. We get 547475.193. Again, column 2 by 1. So we get 547519. Column 3 is 3 minus 4, 2607.151. Column 6, 4 minus 2 minus 5, we get 2868.04. 2868.04 minus 3154.67, then we get 2867.86. Ending balance is column 2 minus column 5. In column 2, you can see 2868.04 is 2867. So there is zero balance left at the end of the year.